Welcome to this video. In this we will solve the entire past paper of mechanics May-June 41 2010. Before we actually start solving the paper, there are three assumptions that I hope you guys have covered. Firstly, I assume that you guys have covered your basic algebra from your IGCSE, trigonometry and physics, and the reason is I want to keep this video concise and easy to follow. So I would not be going through every single step of algebra or trigonometry or your formulas in physics. I hope you guys are well aware of it. Before you actually start solving any past paper, it is necessary that you guys cover your basic content, which I hope you have done so. With that, let's actually start solving the paper. Right. So first question. A car of mass 1150 kg travels up a straight hill incline at 1.2 degree to the horizontal. The distance of the motion to car, okay, fine. So whenever you have your question given in your examination, the first thing to do in mechanics is draw a rough diagram. I've already drawn a rough diagram over here, but in your examination you guys have to make sure that you draw a rough diagram before solving the question, because it makes your problem solving much more easier. So basically we have a situation where you have an object which is moving upwards. We know it is moving upward because it's accelerating, so therefore driving force must be greater than all other forces, and there are two forces acting which are pulling it downwards. The first is your air resistance, which is 975 Newton, and the second is the force of gravity pulling the object down the inclined plane. I have drawn a enlarged image of the object, separate image of the object, which basically shows that the slope is parallel to the triangle which you can draw with your object. Now this is something which you should have covered in your basic content, so I'm going to get through the point straight away. If you want to find the reactionary force of an object on an inclined plane, all you have to do is multiply your mass with your gravity with your cos theta. Theta is the angle of the inclined plane. I won't get into the diagram of how these two triangles are interrelated. Just keep that in mind. Whenever you want to find a reactionary force, multiply your mass with your gravity with your cos theta. Theta in this case would be the angle of the inclined plane. Whenever you want to find the force of gravity pulling the object down the slope, multiply your mass with your gravity and with sine theta. Theta in this case again being the force pulling the object downwards, the gravity pulling the object down the slope. So in this case we want to find the force of gravity pulling the object down the slope, which would be mass, which is 1150, multiplied by gravity, let's just call it g, or you can just write 10, multiplied by sine theta. Theta over here is 1.2. So now with this we can draw our equation. Also, when you have a question in mechanics, it's always important to write down your equation, write down the final equation that you need to get to. It makes the problem solving much more easier. In this case, we need to find acceleration. So basically you have to use F equals ma, Newton's second law. Force is equal to mass into acceleration. So let's understand that what forces are acting on this object. We have three forces acting. We know that the object is accelerating, therefore the driving force must always be greater. So therefore driving force minus 975 Newton, which is the resistance, minus the force of gravity acting on it, which is 1150 g sine 1.2. I'm not simplifying it just so that it's easier for us to follow and so for you guys to understand, is equal to ma 1150 multiplied by acceleration. We don't know the value of a, we have to figure that out. Let me scroll it down 1 second. That's much more easy. Right, so we have an equation where you have two variables. You have acceleration and you have driving force. Clearly in a linear equation with two variables you can't solve the equation. However, we have information given in the question that can help us find the driving force. We know that power is equal to force into velocity. In this case, that force will be your driving force. We know that the power is given in the question, which is 3500 watts converted into watts from kilowatts, and we know that the velocity is 16. So we can create an equation. 35000 watts is equal to driving force multiplied by your velocity, which is 16. Therefore driving force would be 35000 divided by 16. That's your driving force right there. With that we can finally put the values into our final equation. That would be 35000 divided by 16 minus 975 minus the force of gravity 1150 g 00 sine 1.2 is equal to 11150, which is your m multiplied your x multiplied by acceleration. So again we have an equation where you just have one variable, which is acceleration. So we can do our basic algebra and find the answer. Now if you were to do your basic algebra, you would get your correct answer, which is 0.845. I'm not going to go through the algebra over here. I hope you guys can solve the basic algebra. It's a simple linear equation. I'm doing that to save time so that it's a much more concise mark scheme. Now let's move on to question number 2. In question number 2, you have a diagram given. You can read through the diagram. You can pause the video and read through the diagram. The first question is, the first part is find the acceleration of the tool during the first 2 seconds of the motion. So basically you have to find the acceleration in the first 2 seconds. Now we know that this is a speed time graph, and you have to understand that in a speed time graph, the gradient of the curve represents acceleration. So therefore, by finding the gradient within the first 2 seconds, we can find our acceleration. Now you can do that by using the formula which you have studied in your IGCSE maths, hopefully, which is basically y2 minus y1 divided by x2 minus x1 to find the gradient, and you can find the acceleration. That's pretty valid. Or alternatively, you can use Surratt equations. I would prefer using Surratt equation because it is a mechanics paper and it looks more neat. So I just have to use my simple equation for acceleration. Acceleration is equal to final velocity minus initial velocity divided by time. In this case, we have final velocity to be 0.18. 1 second, 0.18. Our initial velocity is 0 and our time is 2 seconds. And if you do just put the values in your calculator, you would get your answer to be, if I put in calculator quickly, 0.09 meter per second. Part 2 of the question: the distance of the tool moves forward while cutting. So basically, in a speed time graph, we know that the area under the curve represents distance. So all you have to do in this situation is to find that distance. You have to find this distance under the curve. Now the question explicitly says while moving forward. So this part over here we will ignore for now, because this is the part which is dragging the chainsaw back towards the initial position. So we can divide this figure into 3 separate parts. We can have a triangle, we can have a rectangle, and we can have another triangle. In this case, the width of triangle is 2, the height is 0.18. 1 second, 0.18. The rectangle, the width is 4, 6 minus 2, and the height is again 0.18. And for the triangle over here, we have the width to be 2 seconds and the height to be 0.18. So we can set up our equation. Area of triangle is equal to 1 by 2 length into breadth, plus our area of the rectangle, which is 4 into 0.18, plus the area of the other rectangle, which is 1 by 2 118 multiplied by 2. Now you could ask, why aren't we using Surratt equation to find distance in this situation? It's a valid question, it's a good question, but the problem is that from time 0 to 8, it's not a straight line graph. The graph is increasing, the gradient is increasing, the gradient is then constant, and the gradient then falls. Had it been a straight line, had it been something like, something like this, for example, a straight line, we could have used Surratt equations. Surratt equations are only valid as long as the curve is straight. When the curve bends, you can no longer use Surratt equations. So if you were to plug the values into your calculator, you will get your area to be, answer to be 1.08. So that's your meters, your area of the chainsaw moving forward. Part number 3. For the greatest speed of the tool during the return to its position. Now, this is a tricky question. You have to understand that in this return journey, there are 2 parts. So you can cut it into 2 parts. You can, if you draw a straight line, you can cut it into 2 triangles, 2 right angle triangles. So the distance, the greatest speed of the tool during the return journey, they basically want us to find the height of the triangle, and if you can find the height of the triangle, we can find the greatest speed. So if we can set up an equation to find the distance of the triangle, if you can find this distance, which we know is 1.08, because this is a return journey. So let me put it this way: if you were to drive a car from here to another town which is 100 kilometers away from here, no matter how fast or how slow you come back, you will still be traveling 100 kilometers back to your hometown. So in this case, we have traveled 1.08 meters forward, so we would come back 1.08 meters again. So if I were to write down an equation for the area of the triangles coming backwards, which wherein the height would be v and the width would be 1.5. 1.5 is 11, the midpoint of 11 and 8, plus the other triangle is equal to 1.08. We have an equation where you just have one variable, and if you were to use simple algebra, you will get the answer of your velocity to be 0.72. Again, let me just call it over there. Again, the purpose of these videos are not for me to go through every single algebra. It's just for me to give you guys a good understanding of the question and make it concise as possible, so that you don't waste time, scrolling through, and it won't be boring basically. So let's move on to the next question. Hopefully you can understand the third part. Let me just explain the third part again, which I think is slightly tricky. In the third part, we are moving a chainsaw back towards its original position. I'm just calling the cutting machine a chainsaw. It's more simpler, honestly. We have traveled 1.08 meters forward, so we would travel 1.08 meters backward as well. All I am doing, I am finding the area under the curve for the return journey. We have two triangles. We can cut the equilateral triangle into scalene isosceles triangle into two equal parts, where the height would be v, which is the velocity we have to find out, and the width would be 1.5. How is it 1.5? Well, because you have 8 and you have 11, and the midpoint of 8 and 11 is 8 and 11 is 9.5. So distance between 8 and 9.5 is 1.5. Distance between 9.5 and 11 is 1.5. So the width is 1.5. All I am doing is setting up an equation for the area under the curve, equating it to 1.08 because that's the distance coming back, and then solving the equation to find the velocity, which is 0.72. Let me just call it over there, 0.72, and that's the answer for question number. In the third question, we have a rod which is being pulled up by a 7 Newton force. We are being asked to find the reactionary force of the object. Now we know that the Newton's third law is every action is equal but opposite reaction. So whatever weight of an object is, it will have the same value of the reactionary force, because the object is in equilibrium. So the reactionary force, or the normal component, will be equal to the weight of an object. Now in this case, there are two forces acting upward. The first force is obviously your reactionary force. The other force is the vertical component of your 7 Newton. The 7 Newton force, if I were to draw a simple right angle triangle, our hypotenuse would be 7, our degree would be 45 degree. We have to find the vertical component, the vertical side, the opposite side, and for that we'll use simple trigonometry, which would be sine 45 multiplied by 7 will give us our vertical component. Now there are two forces which are acting vertical. First is your the vertical component of your 7 Newton force, and the other is your reactionary force, which you will label it as R. This is equal to 0.8 g. Again, the object is in equilibrium, therefore the vertical force will be equal to the downward force. So all I am doing is equating my vertical forces, which are two forces, to my weight, which is my only downward force. So if I were to use my basic algebra, I would find the reactionary force to be 3.05, exactly as the question asks. The part 2 of the question, the ring is in limiting equilibrium. Find the coefficient of friction between the ring and the rod. We know that the frictional component of any force is frictional component is equal to your reactionary force multiplied by your coefficient of friction. Now in this diagram, let me just draw a simple diagram again. You have two horizontal forces. The first horizontal force is the horizontal component of your 7 Newton, and the other horizontal force is your friction. Now we can find the horizontal component of your 7 Newton force by using simple trigonometry. Again, let's go back to a triangle. So over here, this would be sine 45 multiplied by 7, and this side would be cos 45 multiplied by 7. Again, all I am doing is I'm using my basic trigonometry, which you guys have studied in your IGCSE. So if you guys don't understand how I'm getting this cos and sine, make sure to revise your IGCSE mathematics. So the horizontal component of your object of 7 Newton force would be 7 cos 45, and the backward force of friction would be your reactionary force multiplied by your coefficient of friction. Now we know that the reactionary force is 3.05, which we have figured out in the previous part, multiplied by a coefficient of friction is equal to 7 cos 45. So 1 second, why is my pen not working? 45. So therefore our coefficient of friction would be 7 cos 45 divided by 3.05, and if you were to do the maths, you would get the coefficient of friction to be 1.1. Let me just put in the calculator, 1.62, and that's your answer to the question. Let's move on to question number 4. In question number 4, you have multiple forces acting on an object at the origin O, and the question is to find the magnitude and the direction of the force. In these type of questions are extremely common in your exam. All you have to do in these type of questions where you have been asked to find the resultant or the direction of a force on an object, all you have to do is make two equations, probably simultaneous equation. One equation would be for the horizontal component of the resultant force, the other would be for the vertical component of the horizontal force. Let's start with the vertical component. Let's just call it y. Force in the y direction. Y direction means the vertical direction. If you look at the diagram, there are two forces acting on the vertical direction. The first is your 370 Newton, so we will write that down, 370 Newton, and the other one is the vertical component of 250 Newton. Now because this is acting downwards, it will be in negative. Now we can use our basic trigonometry to find this force. This would be minus 250 sine, because we have to find the opposite side, sine theta or sine alpha. Now this is our vertical component. Now because the object is in equilibrium, because the object has a resultant force, we will have a value for this. Had it been in equilibrium, it would be equal to 0, which is not in this case. Now we know that the value of sine theta is 0.96 from the equation itself. So therefore the vertical component is 370 minus 250 multiplied by 0.96. And if you were to put the value in the calculator, you should get the answer to be, let me put in the calculator, you should get your answer to be 300 Newton. Now this is our vertical force. Now we have to make an equation for our horizontal force, and basically the forces in your x direction. Again, all I'm doing is I'm making two equations, one for the vertical force, the other for the horizontal force. Now there are two forces acting horizontal in this scenario. The first force is obviously the horizontal component of your 250 Newton force, and the other one is the 160 Newton acting on the other direction. So therefore we will have an equation to be 160 Newton minus, because the 250 Newton is in the negative side of the axis. Simple algebra. In a graph, these two sides are positive, these two sides are negative. Any values over here, anything over here would be negative. In this case, 250 is in the negative side, so we have to find the adjacent side. So therefore we will multiply 250 by cos theta. Again, the value of cos theta is given in the question to be 0.25, so 160 minus 250 multiplied by 0.28, sorry, and that should give us our horizontal force, which is equal to 500 Newton. And you have been asked to find the resultant force and the direction. To find the resultant force, all you have to do, resultant force, all you have to do is take the modulus of both your values, basically the root of the squares of both value, 300 square plus 500 square. That's your magnitude. If you want to find the direction of your force, all you have to do is tan inverse opposite by adjacent. In this case, our opposite force, which is basically your vertical force, is 300 Newton, and our horizontal force is 500 Newton. And if you were to plug both of these equations into your calculator, you should be able to get your answer. And if you were to do that, your answer, the magnitude would be, if I put in the calculator, would be let me just put it in the calculator, 1 second. This gives us 583.1 Newton, so resultant force. Our direction would be tan of both of them, which is 30.96, and that's your answer to question number 4. In question number 5, you have an object which is moving upwards on a plane on an inclined object. Make sure to read the question, and whenever you have a question given, again, the first thing to do is to draw a rough diagram, which I have done over here. The first part asks us to find the speed of the object, where the speed at which the object moves to. So basically, you have an object being launched from somewhere on the plane, and it moves like beyond q. The question is, what is the possible speed of the object as it reaches q? Now they have given a caveat, and the caveat is that the surface is smooth. Whenever the surface is smooth, you have to keep one equation in mind. Whenever the surface is smooth, the gravitational potential energy is always equal to kinetic energy. Why? Because there is a 100% conversion of energy. There is no energy being lost because the surface is assumed to be smooth. Now obviously, if you were to write down an equation for kinetic energy, which is 1 by 2 m, which is 0.3 given in the question, v square. Obviously we don't have velocity, which is something you have to find out. However, we can write a complete equation on the left hand side. Gravitational potential energy is mass into gravity into height. Mass is given to be 0.3, g is your gravity, and height is 0.45. 0.45 height of the object, height between p and q given in the question itself. If I were to solve this equation, I would get my answer of v to be 3 meter per second, and that's your answer right there. Part 2 of the question is slightly similar, with the only caveat is that the surface is rough and the particle passes through p with the same speed as it is found in part 1. In part 1, the speed by which the particle passed p and q will be the same, which is 3 meter per second, and the reason is pretty straightforward, because the surface is smooth. In part 2, you have the same speed by which 3 meter per second by which the object is passing q. The question is, find the work done against friction of the moving object. Okay, so the work done against friction is given to be the work done against friction is given to be 0.39 joules. The potential energy gained by the vehicle, so to define the height, so so basically the question is that you have an object which is thrown from point P to point Q, and the thing is, and one second, let me just put it over here. Okay, so your object is being thrown from P to Q, not thrown, slided from P to Q. The surface is smooth, therefore the object comes somewhere in between P and Q and stops over there. The question is, what is the height of this point relative to P? How tall is it? How far is it in terms of height from P? And the work done against friction is given, and we know the GPE to be mgh is given, which we can find out, and we also have velocity. So you have to write down an equation to find the height above P. So basically, for the object to stop in between P and Q, how do I put it? The kinetic energy must be able to overcome the gravitational pressure energy and the resistance. So therefore the equation would be mass, which is 0.3, multiplied by gravity, which is g, multiplied by 0.4, sorry, multiplied by height. We don't have the height given, so that would be our variable, multiplied by h, gives us our 1 by 2 m, our kinetic energy, v square, v is 3, plus our resistance, plus our work done against force, our work done against the work of friction done on the object, which is 0.39. If I were to solve this equation, I would get my answer to be 0. One second, I wrote the entire equation incorrectly. I'll explain in 1 second. Plus 0.39 is equal to 1 by 2, 0.3 m, v is 3, mv square. If I were to solve this equation, I will get the value of h to be, if I solve it quickly, value of h to be, 1 second, hold on, value of h to be 0.32, which is basically your height of the object above the P. Now what am I doing this equation over here? All I am doing is equating, so I'm assuming because the object is stopping somewhere between P and Q, it must be that the gravitational potential energy of this object must be equal to the kinetic energy plus the work done against resistance. Why? Because the object is stopping in between. Let me put it in simple words. If you're climbing some stairs, and let's say the gravitational pressure energy, the theoretical gravitational pressure energy of you climbing up the stairs, let's say 100 joules. The fact that you climb up the stairs with your friction and with your kinetic energy, it shows that both of those energy added up to give us the GPE. Both of the energy added up to give us the GPE, and this is exactly what we are doing over here. We are adding, both of the energy add up to give us our kinetic energy. That's exactly what we are doing over here. We are adding up our GPE and we are adding up our resistance to find our height, and that would be your answer to question number 5. In question number 6, you have an object which is being dragged down along a smooth pulley. In the first part, you have a bunch of details being given to the question, so make sure you read the question properly. The first part says, find the acceleration of the particle and show that the speed of B immediately before it hits the floor is 0.95. Correct with significant figures. So basically, the object is moving downwards. The object is moving in this direction towards the floor, and they want us to find the speed of B as it hits the floor. In the question, the height of B relative to the ground is 2 meters. It's 2 meters, it's 2.1 meter, not 2.3 meters. 2 meters minus 0.7. That's the height of B relative to the ground. The height of B relative to the pulley is 0.7. The height of A relative to the pulley is 2.1. All of this is already given in the question, so we need to find the velocity by which the object hits the floor. Obviously, we'll have to use Survey equations for this. But the question is, what details do we have? Do we have final velocity? No. Do we have initial velocity? Yes, which is 0. Do we have distance? Yes, which is 2.3. Do we have what? Sorry, not 2.3. 1.3. 2 minus 0.7 is 1.3. Do we have acceleration? No. Do we have time? No. You can't solve a Survey equation with only 2 of the 5 variables. You need to have at least 3. We can find the third one. You can find acceleration by using our F equals to ma formula. Force is equal to mass into acceleration formula. Now we know that our particle A, the particle A has a mass of 0.2 and particle B has a mass of 0.56. We know that the particle A is being pulled towards Q. We can say that the tension on particle Q, particle P, is greater than the resistance of the particle P, the friction of the particle P with the ground. The coefficient of the friction is given in the question to be the friction is given in the question to be 0.3. So because it is moving towards B, the tension will be greater than our frictional force. For B, because it is moving downwards, the tension will be smaller than the gravitational force of the object. So we can create two simultaneous equation situation. For particle A, for particle A, tension minus the force of friction acting on the object. What is force of friction acting on the object? Force of friction acting on the object is 0.1 second. The force of friction is your normal force multiplied by your coefficient of friction, the external force multiplied by coefficient of friction, which would be 0.2 multiplied by 10 multiplied by 0.3. Why? Because the coefficient of friction, okay, I was reading it wrong the whole time. The coefficient of friction is 0.3. The reactionary force is 0.2 multiplied by 10. Why? Because Newton's third law, the weight of the object in this situation will also be its reactionary force. So is equal to MA. M is 0.3. Let me just erase that quickly. Is equal to MA is equal to M, which is 0.2 multiplied by acceleration. That's our first equation. The second equation we can write an equation for B. For B, because it is moving downwards, the weight is more than the tension. So therefore 0.45 G, which is the weight of the object, is greater than greater than the tension, which is equal to mass, which is 0.45 into acceleration. Again, I'm just using my F equals ma formula and writing down two equations relative to the tensions for particle A and particle B. I have a simultaneous equation situation which I hope you guys are able to solve. You should be able to solve by now. And if I were to do that, I would get my acceleration to be 0.6 to be 6 meter per second, or 6 meter per second. And now I can simply use my Stewart equations and find the answer, to find the velocity before the B hits the ground. I know I can use the Stewart equation. V square is equal to u square plus 2as. Our acceleration is given, our initial velocity is given, so v2as. Our s is also given, which is 201.3. We can use simple algebra and you can find the value of b, and that would be answer for question number 6. Last but not the least, question number 7. The vehicle is moving in a straight line. Okay, the equation for velocity is given. V is equal to a multiplied by t minus 0.5 t square between 0 and t and 15, and the equation for v is above 50 is also given, v by t squared. This is for t is greater than 15. The first part, find the value of a and find, so the distance between, so a and b are two constants. The distance between the travel, okay, the distance is 2 to 5, okay. The distance between time 0 and time 15 is 2 to 5 meters. Find the value of a and b. All you have to do is set up an equation for a and b, set up an equation for distance, and find the value of a and b. In this situation, we have the equation for velocity given. Now we know that when you take the integration of the velocity, you will get distance. So if I integrate these two, if I integrate this equation with my limits to be 0 and 15, theoretically speaking, I should get my distance. So I'll draw down a simple equation from 0 all the way to 15. Integration of a t minus 0.5 t square is equal to 2 to 5. Why? Because you know the distance between 0 and 15 is 2 to 5. So if I integrate that, I should have 0, 15. This would be a t square 1 by 2 a t square. 1 second. We have 1 by 2 a t square minus 0.5 t cubed divided by 3. All I'm doing is I'm integrating them. And if I were to solve this integral, I should get the value of a to b. I should get the value of a to b. 1 second, and put in a calculator. I should get the value of a to be 4. Again, you can go through the algebra yourself. I'm trying not to go through algebra so that it's easier for you guys to follow. Now I know that for the second equation that the velocity beyond time equals 15 is greater than equal to 50. But we know that the distance at 15 seconds is 2 to 5. So we can make an equation for the derivative of the equation beyond 15 seconds and equate it to 2 to 5 to find the value of b. Alternatively, there's a different method. What we can do is we can find the velocity of v at 15 seconds, and that would be your answer right there. From the first equation, we know that a is 4 when t is 15, or a is 4 throughout the equation. So v is equal to a. We want to find the acceleration at the velocity at 15 seconds. A is 4, sorry. A is 4, 15 minus 0.5, 15 square. And if I have to put it in my calculator, I should get the value of v to be I should get the value of v to be 15. So right now I can make an equation for my the second part. I know it's a bit confusing, but hopefully if you do a few past papers, it should become easy. I hope you guys give me some feedback so that I can improve my presentation too. So 15 is equal to b by t square. I'm writing down the equation for the second part beyond 15 seconds and equating to 15. Why? Because the velocity at 15 seconds is 15. So if I were to solve this, I should get the value of t to be, I should get the value of, sorry, t should be 15 over here. So basically b would be 15 square multiplied by 5, 15. That should give us the value of b to be 3375, which is your answer. Moving on to part 2, let me erase this super quickly. Moving on to part 2, find the expression in terms of t for the total distance traveled by the vehicle beyond 15 seconds. So we have to find the integral of v is equal to b by t square. Now we know that the value for b is 3375, so therefore this would be integral of 3375 t minus 2, I'm using laws of indices, dx, not dx, sorry, dv. This should give us, if I do my algebra properly, 3375 t raised to minus 1 divided by minus 1 plus c. S is equal to plus c. Now I know that the distance covered at 15 second, is 225. So I can 225 is equal to 337. Let me just put it over there. 337 t, which is 15 raised to minus 1 divided by minus 1 plus c. If I were to solve this equation, I should get the answer for c to be, 450 using my calculator, and that's the answer for c. So our final equation would be s is equal to 3375 t raised to minus 1 divided by minus 1 plus 450. Now of course you can rearrange this equation differently to make your powers positive, but honestly you don't need that in your exam. This would be your final answer.